Okay, so this is going to be a quick review of difficult factoring. Dun dun dun. So what do I mean by that? Well, this is a factoring series because the reality is that factoring is actually a very large topic, so it's hard to get it all in one video if you're really trying to review it. Part one was the basics, so if you just needed a really quick review, this is a better place to go. But if you really have to master factoring again, then this is going to be the video for you. But you need that foundation first. So if you struggled with part one, I would say do some of the practice problems that I have with that before you move on to part two. Okay, so let's get into it. So we are going to talk about first things first, combining factoring techniques. So in the last video, I talked about greatest common factor grouping and trinomials of this form, x squared plus bx plus c, plus also the difference of squares. So the first thing I want to do is kind of a review and just combine all those things. So looking at problem A here, so this is kind of like one of your classic combining techniques problems. So looking at this, I noticed that this says 4x squared. So whenever this is not just x squared, usually the first thing I try to do is see if there's a GCF, which there totally is in this case, right? So I can divide everything by 4. So if I take the 4 out, this is going to leave me with x squared plus 2x plus 1. And the thing with factoring, the thing that you have to get used to is that after you have factored something, you always want to ask yourself, can I factor this again? And so x squared plus 2x plus 1 can totally be factored again. This can be factored as 4 times x plus 1 times x plus 1. So you'll just notice, right, this GCF of 4, it came along for the ride, and then we just factored out the rest of this stuff. So this was 3 terms, so this was both a trinomial that we could factor and a GCF. Now let's compare that to the next example, which has 1, 2, 3, 4 terms. Okay, so usually if you have more than 3 terms, a lot of times it can be grouping. It doesn't have to be, but it could be grouping. But also the first thing I want to look for always is just a GCF. And so I notice here I have an XY in every one of these terms. And then all of these numbers can be divisible by 2. So if you are familiar with the GCF, you should be able to write down kind of what your guess of it is. So I am going to factor out 2x squared y. And let's see what that leaves me with. This leaves me with 5 plus, let's see, 5 plus 10z minus x squared minus 2x squared z. And so you can see how these are like 2 very different problems now, right? So for this one, I factored and I got just this nice trinomial. But here, now I still have this big old mess that I have to use grouping on. And so you just kind of have to like watch out for it and organize yourself pretty well. So what I'm going to do next is I'm going to make myself some room. And for whatever reason, people get a little bit in their heads about grouping. So grouping this whole thing. So if you find that it feels a little overwhelming now to have to like group this, just like do it in the margins or do it on the side or something, just so you can kind of see how it's going to end up grouping. So I'll do everything in gold for just focusing on the grouping part of this. So looking here, I notice that now out of these 2 terms, I can factor out a 5. So I'm going to factor the 5 out, and that's going to leave me with 1 plus 2z. And then out of these second 2 terms, it looks like I can factor out a negative x squared, which is going to leave me with 1 plus 2z. And so now I can see how this whole thing will factor. So this becomes 5 minus x squared times 1 plus 2z. And so now that I've factored just this part, so you don't want to forget about the GCF. So the final answer then is going to be 2x squared y, 5 minus x squared, 1 plus 2z. Okay, so I have another one here. So, you know, if you're playing along at home here and you're trying to get better at this, I'd strongly recommend you pause here and give this one a try and hit play when you're ready. Okay, so for this one, so it looks like I can factor out the 5. So if I factor out the 5, I get x squared minus 10. And so this is also the other thing. So you might see x squared minus 10 and then think, oh great, this is going to be a difference of squares. But 10 is not a perfect square. So one of the things when you are thinking about combining techniques is you still have to also think about when is it appropriate to stop. And so in this case, I can't factor this any farther. So I could definitely factor a 5 out, but that's really as far as it goes. So anything can really happen with factoring, and you want to stay on your toes for it. So let's try another one. So again, maybe pause here, give this one a try and see if it's any different. Hit play when you're ready. So in this case, I can see that I can definitely factor out 4y first, which is going to leave me with x squared minus 1. And so this is a totally different problem now, right? Because in this case, I can actually use that difference of squares setup. Boom, 4y times x minus 1 times x plus 1. So again, it just 100% depends on the problem, and you have to stay on your toes. So moving on to this last one. So again, I'd strongly recommend that you maybe just pause for a second just to see if you can get it, and then hit play when you're ready. So I notice the first thing I can do is factor out 5y, which is going to leave me with x squared plus 5x plus 6, and then that can totally be factored. So the 5y stays in the front, and this is going to be x plus 3 times x plus 2. So that's all we have to do for that one. So that's combining techniques, but now I want to talk about harder trinomials of the form ax squared plus bx plus c. Okay, so in the previous video I had talked about doing two different methods, the trial and error method versus the AC method. I'm going to talk about those again. So I will say trial and error is always going to be my favorite, because with trial and error, there's really two things that we have to think about. I like it because the directions are simple. So the first thing that you want to think about are what two things can you multiply together to get the first term? And this is 2x squared, so there's not a lot of things that are going to make that right. So it's going to be 2x and x. And then you ask yourself, what two things can you multiply together to get the last term? And in this case, it is going to be 1 and 3. And this is really trial and error in its essence. It's what do you multiply to get the first term, what do you multiply to get the last term, and then ideally you check to see what you got in the middle, and ideally what you would be able to do is to check that in your head. Now, I'll show you this two ways. So as I go through and check this, so first I just check the first term, 2x squared, we're good there. Last term, 1 times 3, we're good there. So then how could I check if this is the right middle term? So what I'm going to do is I'm going to take 1 times x, so I take the inside terms times the outside terms, and then 3 times 2x. So this is going to be, this part here will be 6x, and the inner part will be 1x. Now, if you can't visualize that, that's just something to practice, and over time you will get better at it. But you do, like, that's kind of one of the keys with trial and error is that you can check that middle term without having to multiply everything out. But also sometimes you're just having a moment and you'll have to multiply it back out, and that's totally fine. So I can see that if I were to go through and multiply this all together, I get 2x squared plus 7x plus 3. And so obviously that is not what we wanted. And so then just how do you troubleshoot that? And so that's where this is like a trial and an error. You try something and you see what you get. Now, the key to this is to analyze what happened in the middle. Why was this such a big term? And that's why understanding the structure of how this all multiplies together matters so much. So the reason that this is a 7x is because the 3 and the 2 bounced off of each other, right? So once this became 6x, you know it was too big for that middle term. So part of trial and error is that you make very educated guesses on this. And so really what I want to have happen if I make another guess is I don't want the 3 bouncing off the 2. But there's only one way to make 3, right? It's only 1 times 3. So my only way to resolve this is to switch the 1 and the 3. So if I try this again with 2x plus 3 times x plus 1, so then I get 3x plus 2x, and that totally gets me 5x, right? So this is the right one. Now, the other way to do this is the AC method. So there are pros and cons to both. So I will just show you the AC method first. So for the AC method, the first thing that you want to do is you want to multiply these two numbers together. So the first number and the last number. So 2 times 3 equals 6. Okay. So you want two numbers. You want two numbers that multiply to this number and adds up to, adds up to the middle number. So two numbers that multiply to 6 but add up to 5. So that can be easier to think through than making a guess. So those two numbers would be 3 and 2. So now what we have to do is we want to break up. So we want to break up the expression like that with these numbers, really with these numbers. Okay, so what does that mean? Okay, so let me clear a little space here. So what I'm going to do is I'm actually going to break up the middle term now into this 3 and this 2. So this is going to become 2x squared. I'll actually write this as 2x squared plus 2x plus 3x plus 3. So I was a little strategic in how I decided to break everything up. But now you'll notice, right, 2x and 3x make 5x, so we're all good. We didn't really change the value of the expression. We were just strategic in how we broke it up. And now I can use grouping. So I can factor out the 2x, so then this becomes x plus 1, and the 3, so that this becomes x plus 1. And this will be 2x plus 3 times x plus 1. And that is indeed what we got for our trial and error. So which is better? Is it the trial and error method or the AC method? So I will tell you that in the long run, I think the trial and error method is better because it's faster, but I know it's more frustrating. The problem with the AC method is that most people forget it. They forget it all the time and then they use it incorrectly. Versus trial and error is like a pretty easy thing to remember because it's just figure out what multiplies to the first thing, the last thing, and see if it works. So it's kind of up to you how well your memory works, how much you want to study these things. But using the AC method to factor every single time will take you forever. So you are eventually going to have to kind of get okay with trial and error depending on what you're reviewing this for. So the AC method is really good in a pinch though. If you really can't figure something out, it's awesome for that. So there's pros and cons to each, and so you have to kind of decide what works for you. So what I would recommend is let's try both here. So let's actually try the AC method again here with part B. So why don't you try factoring this according to the AC method, and then we'll try C by trial and error. So what I want you to do is I want you to pause the video, try both of these, and then hit play when you're ready. Okay, so I'm going to start with part B, just using the AC method. So to remind you how this works again, so first I'm going to take 7 times 2. 7 times 2 is 14. So I need two things that multiply to 14 but add to 15. So of course that's going to be 14 and 1. So that's how I'm going to break up this middle part here. So this is going to become 7x squared plus 14x plus x plus 2. And so now I can factor out the 7x so that this becomes x plus 2. And then I'm going to put a 1 here so that this is x plus 2. So this will factor as 7x plus 1 times x plus 2. So that's using the AC method. So let's compare that then to part C here. So just using trial and error. So for trial and error, so what I'm going to do is I'm just going to set these up. So first I just think about how do I make 5x squared. So for 5x squared, I need 5x and x. That'll get me to 5x squared. And then how do I make 3? So I could write 3 and 1. And so now I've at least made a guess. And the key to this, right, is that you now do a quick check in your head. So I know I've got 5x squared, 5x times x. I've got the 3 at the end, 3 times 1. What about the middle term? 3x plus 5x will give me 8x. So this will not work, but why was this so low? It was so low because this 5 is just being bounced off of a 1. So what I'd want to do to change this is, again, just flip the numbers. So this is 5x plus 1 times x plus 3. So this is going to be now 1x plus 15x. That will 100% get us to where we need to go. So it's all about just making those educated guesses and just being okay with like, yeah, this one might not work, but then I'm going to make a better guess the next round. And so again, it's whichever one you like better. So I have 2 more here. So once again, I will do the AC method for D, and I will do, actually, you know what? I'll do trial and error for D, and then I'll do the AC method for E. So that's going to be the way I go with those two. So if you want to try those two, pause here, give it a go, and hit play when you're ready. Okay, so doing trial and error for the first one. So this is going to be 3x and x. and then plus 5 and plus 1. And so 5 times 1 will give me the 5, 3x times x will give me the 3x squared, and then I have 5x plus 3x, so I have 8x. Okay, so now let's compare that to the AC method. So I'm going to have 15 times 2 equals 30. So I need two numbers that multiply to 30 but add to 13. And I can tell right away that that's going to be 10 and 3. So that's going to be how I break this up. So this is going to become 15x squared plus 10x plus 3x plus 2. And so now I can factor out of these first two terms, I can factor out 5x. So this becomes 3x plus 2. And then I'll just put a 1 here. So this becomes 3x plus 2. So this will ultimately factor then, let's see, I'm kind of running out of space, but I'll cram it in over here. 5x plus 1 times 3x plus 2. And by the way, if you're finding this video helpful, please consider hitting that like button, subscribe button, or leave me a comment and just let me know how it's going for you. So now we're going to discuss the sum and difference of cubes. And you know, I usually don't like having formulas, but unfortunately with the sum and difference of cubes, you 100% just need to have formulas. And so these are the two formulas. So I have a cubed minus b cubed is a minus b times a squared plus ab plus b squared. And then a cubed plus b cubed is a similar formula, but it's a plus b times a squared minus ab plus b squared. Now, if you are in a situation where you need to remember these, I do think that there are a few things that make this a little bit easier. These are very, very similar formulas. The good news is that, so for a cubed minus b cubed, it starts with a minus here in the smaller term. The rest stays positive. Now notice how that's kind of inverted for the other formula. So I have a cubed plus b cubed starts with a cubed plus b cubed, and then that middle term is the opposite. So that's kind of what helps me remember, is that like the smaller term follows the same sign, and then this will be the opposite. Smaller term follows the same sign, and then this one has that opposite sign. So that's just how it works in my brain. And then just to help you out, here is a list of cubes in case you need them. So feel free to pause and write these down or whatever you need to do with them, but you do need to know your cubes pretty well so that you can work on these. So let's talk then about x cubed plus 8 cubed. So how am I going to factor this? Okay, so one of the things that I think is really helpful when you are first getting started with this is for you just to appreciate what the formulas look like. So maybe we'll write them down first. So coming back here, let's just write out what the formula is. And so now looking at this, what I really need to do is I need to be able to describe what stands for the a, what stands for the b. So in my a cubed place, I have x cubed. So what that means is that my a in the formula will be equal to x in this situation, right? And then in my b cubed spot, what do I have? I have 8. And so if I go to my list of cubes, 2 cubed is 8. So it is the 2 that is going to be in that spot for the b. So my b equals 2. So this is kind of what you want to do when you're first getting used to this. And then you can really just like plug this x and this 2 into the formula. So this will turn into x plus 2, x squared minus 2x plus 2 squared. And of course, then you're going to want to write that out so that it's not 2 squared, but just 4. And so that'll be the way that you want to write that out. And so that's how this is going to work. So if I move on to like x cubed minus 125, so again, we want to do the same thing where we write out the formula. And then we have to identify what's in the a spot, what's in the b spot. So I would challenge you to pause the video here and try this on your own just to see if you can get it, and then hit play when you're ready. So in this case, in the a cubed spot, I have x cubed, so that means that my a will equal x. And in the b cubed spot, I have 125. So that means then that my b must equal 5, again referring to that list of cubes. So 125 is 5 cubed. So plugging everything in now. This is going to be x minus 5, x squared plus 5x plus 5 squared is 25. Okay, So let's try that again. I've got just 2 more examples here just to make sure that we've really got it. So if you feel like you're doing okay with this, I'd strongly recommend, even if you feel like you're not doing okay with this, I think you should still try this on your own. So I am going to just write down that formula one more time. So give it a go. Hit play when you think you've got it. So in my a cubed spot, I have 8x cubed. So what that means is then my a will be just 2x. And in my b cubed spot, I have 27, so that means that my b will just equal 3. So this will factor then as 2x plus 3 times all of 2x squared, so we're going to have to be careful with that, minus 2x times 3, and then plus 3 squared, which is 9. Okay, so the fact that this is now just a bigger term, this 2 and this x, this just makes this slightly more complicated. So when I take 2x squared, remember I have to square both the 2 and the x. So the final answer here is going to be 4x squared, and then what is 2x times 3? That's 6x. And then plus 9. So there's your final answer. Okay, and so I've got just one more in the same vein. So again, I'll write that formula down. And once again, I'd say pause, give it a try, hit play when you're ready. So in my a cubed spot, I have 125x cubed. So that means that my a will equal 5x. And in my b cubed spot, I have 27y cubed. So my b is going to be 3y. So this will factor 5x minus 3y times 5x squared plus 5x times 3y plus 3y squared. And so then this will be 5x minus 3y. So this will be 25x squared, 15xy, and 9y squared. So there's definitely some work that goes into these. Now remember, you can't master math just by watching a ton of YouTube videos. It's better if you practice it. So if you're really trying to review this and be able to use this, I have an additional practice problems set. So I have a PDF of problems with an answer key and then just another video showing you how to work out any of these problems if you need to hear these explanations again. So if you're trying to master this, use that to test yourself on how well you're doing with this. You can go to divideandconquermath.com, just go to the review section. And also, my review series has many other topics in it. It's not just factoring. So each topic includes a refresher video, which is what you just watched here, practice problems, an answer key, extra videos with worked out solutions in case you don't understand the answer key solution. So all of these are organized at divideandconquermath.com. Just go to the review section and you can find everything for free. And so I am going to leave it at that, guys. I hope to see you in the next video. Bye!